Hey guys, welcome to PC Perspective. Apologize for the late start, but we are here to talk about the brand new AMD Radeon HD 7970 GHz Edition GPU. This is the newest GPU from AMD. They're calling the fastest and most versatile. We'll talk with Evan about what all of that actually means. First, let's introduce him. Evan Groenke, Product Manager, Desktop Graphics Product Manager at AMD. Thanks for coming all the way down and fighting with the technology with us for a little bit.
Happy to be with you, and I know technology can be fun, and I was completely impressed at how quickly you guys transitioned over there. I don't think I would have been able to do it myself.
Yeah. Next time we'll know better. For tomorrow we'll know better. So we move forward and we move on. So let's focus on what we're here to actually talk about. We're here to talk about a new Radeon AMD graphics card. We have one up here in front of us running. We've got actually got a couple of them. 7970 GHz Edition. I think most people will be able to realize what that means in terms of clock speeds, because we're running at least a gigahertz. So let's start with a little bit of a discussion on kind of your philosophy behind the card. Why you guys, you initially released Tahiti in, I guess, December or January, kind of in December, early January, and why the move to this new iteration of Tahiti?
Well, you mentioned when we initially introduced it in December, January timeframe. Actually, it was December 22nd, exactly 6 months ago. So that's why, it's the half birthday of Tahiti. So a little bit of a celebration, and we get to talk about a new product based off Tahiti right now as well. Really excited to talk about it because in the span of 6 months, a lot of things have happened. The 7970 was the first 28 nanometer GPU out the door through TSMC out of any graphics card manufacturer. And as most people know, things move very, very fast in technology. There's lots of improvements from the fabs, process improvements allow you to have higher clocks, better products definitions. So 6 months down the road, we're actually able to benefit from Tahiti being the first one out the door, and then us having launched two other GPUs, the 7700 series and the 7800 series. And now we're able to come back and actually really crank it up with the 7970 GHz Edition.
I think it's funny, you've got the happy half birthday. When we were actually at the AMD Fusion Developer Summit, when we first were learning about this new GPU, AMD actually had a birthday cake there to celebrate in the shape of a Radeon 7900 card. It was actually kind of fun. So yeah, let's step through some things.
Well, sure. So you already mentioned it. We are calling this the world's fastest and most versatile GPU, and really, it's there's three real main components from that. This is the world's fastest GPU when it comes to gaming graphics. It's designed for those ultra-high resolutions, high level of graphic detail, high levels of AA. So we're talking about, your 2560 by 1600 panels, which, aren't necessarily cheap, but for those enthusiast gamers, that's what they really want to have.
We talked about a lot on our podcast and in technology in general. Have you heard about like those super low cost, what were they, Korean monitors, 2560 by 1440 that you can buy for like $310, $320 US. Yeah.
Wow.
So I think an adoption of, I think the brand we always talk about is Catleap. So that shows you just how not US based these companies are.
Absolutely.
But you can get a monitor at that super high resolution for fairly low cost now.
That's actually really impressive.
3 of them for under $1,000.
Well, that leads into my next reason why it's the fastest GPU is like multi-display gaming, right? And so I was going to think like, 3 1080p displays. And you can get 3 1080p displays, you run 5760 by 1080 with 3 of those 1080 panels, and it's usually cheaper than one of those traditional 25 by 16 panels, but now you can get 3 of those for $300. That makes it even more interesting.
Yes. So I think we have separate discussions and articles kind of planned for all that kind of stuff because of, it's, long story short, you're taking a chance. You're buying from a company you've never heard of before, but we've had some good response. So.
Well, that's cool.
Yeah.
Well, and the other thing is too is that everybody's been talking about beyond 2560 by 1600. There's these 4K displays as well. So, that's what this graphics card's really designed for. Really pushing it. It's a $500 graphics card, and running it on a 1080p display where you can get for under $200, it's just kind of sort of positions it that, is that type of consumer that's looking for it.
Yeah, we often people ask us about what components they should upgrade next in their system and that kind of thing, and we very often point them to, you should really look at your display, because most people don't think about upgrading that very often, right? You know, they just think about, well, it's a monitor, right? But the difference of a 22-inch 1080p screen and maybe a 27 or 30-inch monitor that exists today can drastically change your gaming experience, regardless of what hardware is even behind it.
Yeah, absolutely. I'm one of those people. I know myself. I usually only replace the display when it dies.
Yes. Yeah.
But everything else is replaced before then. Yep. Even if it's fully functional. So, you know, it's from a gaming perspective and the really high resolutions, that's what you're looking at. But also, it has another aspect. You know, we've been talking about compute and how powerful the 7900 series is in terms of compute performance. And typically, when everybody thinks compute, they think applications like calculations and stuff like that. But there's more to it. There's gaming behind it as well. When DirectX 11 was released alongside Windows 7, Microsoft introduced Direct Compute. Right. We also have OpenCL. And now that there's a very, very big installed base of DirectX 11 GPUs, all the way from our very affordable Brazos APUs, and then up to our high-end, you know, 7970 series graphics cards, we've got this huge install base now. So you get this incredible gaming experience, but with all this wide install base, you get these consumer applications as well. Right. So you get twofold. You get the compute power in games, and you get the compute power in consumer applications like Photoshop, Handbrake, which is coming out soon, the full release. Yeah, and that has really been the promise of GPU computing for almost a decade, right? That's something we've heard about when we first started. I think the very first application was, you know, video decoding, right, on the GPU. That was a big deal 6, 7, 8 years ago, maybe even more recently than that. But it's always been the idea of, you know, NVIDIA and AMD both have really pushed, we can use this processor for more stuff. And I'm glad to see some of the applications that you showed us in the reviews guides, and we'll demo a couple of here, that really take advantage of the GPU for more than just better graphics and performance. Yeah, and what you're seeing now is you're seeing this really, really rich ecosystem for that now. You know, you have the APIs, you have the hardware, and now you've got the install base, so it's really coming together now. Cool. So, and also, there's one other thing I really want to talk about is basically this partner engagement we have now too. The Graphics Core Next architecture in the 7900 series, and as well as our entire 7000 series, you know, the 7800 and the 7700 series, is an entire new architecture. It's really great for compute. And we're working very closely with our ISV developers, you know, Codemasters that just released Dirt Showdown. And we're putting all this really, really incredible tech into these games now, alongside with our partners that take advantage of this compute there, that add these really, really complex and graphic-intensive features there that you wouldn't get previously. And we have a demo that you guys built to show off to those guys that we'll get to a little bit later in the program. So absolutely. I think it's really cool, and to see how it can be applied to gaming. Obviously, it's going to mean a lot to our viewers that are obviously PC gamers, and how it relates to applications like Handbrake that I'm guessing a vast majority of our users use very, very regularly. Absolutely. I'm very excited. Popular transcoding app. I'm very excited about that. Yeah. So, you know, let's get right into sort of like the product there itself. You know, I'm sure most of your readers have seen the review live now. I hope they've read our review. Yeah. Yeah, they should have. And this is going to, you know, they've seen the specs. So essentially, we have the GHz Edition. Like you said, the product name kind of indicates what it is. This is our third GPU in the product family that is shipping at a 1 GHz clock. As a base clock, hence the GHz Edition moniker. It's our full Tahiti GPU configuration, 2048 stream processors. But you notice there's this other clock beside the 1 GHz there. Yes, yeah. It's 1 GHz / 1.05 GHz. Yeah, so what we've introduced with this here is another technology. We've been able to go back to our PowerTune technology, refine it, improve it, and now we have PowerTune technology with Boost. Okay. So that's really cool. It really allows you to extract even more out of the GPU than we were doing before. So you're using every last little bit there. And you know, the general power window that we're operating here is roughly the same power window that we had with the initial product. So you're not looking at a upper threshold any higher than what you were before, but you're using more of that all the time. So to be fair, I think it's fair to say that while you're not, while the upper threshold is the same, in general you will be using more power
with this card because it is able to adjust its clock and voltage dynamically.
Yeah.
In our own testing that we'll get to later, we did see 25, 30 watts additional power consumption in comparison to the original 7970.
But you also have the performance to go along with it.
Yep.
And we're also running at a faster memory clock speed as well. We initially went out with a 5.5 gigabit per second clock speed. The memory devices have improved. That was the fastest memory device at the time. And the memory devices have come along as well. So now we're running at a faster memory clock speed. So we really cranked it up in a number of different aspects.
I'd say I think we're talking about an 8 to 9% core clock increase and a memory clock increase. So we should, in guesstimation, see something at or above that in terms of actual performance increase in games that are compute or shader limited, performance limited. So.
Absolutely.
Okay.
Absolutely. So we talked about PowerTune technology with boost. So what is that? So it's a couple different things. We now have dynamic voltage boost. So previously, at a high performance state, you were at a set voltage, and you are basically working at your high-end, high-state clocks within that voltage. Now, with Power Boost, we're able to dynamically control this voltage and increase our performance and run higher clocks.
So on the previous 7970, the active voltage, the kind of the high end, we'll say, the high performance voltage was static.
Yes.
Correct. And PowerTune, as it existed, was that in the 6000 series as well?
Yeah, it was with the 6900 series.
6900 is where it came out, and that was really kind of an answer to those applications like Furmark and OCCT that forced vendors to lower their clock speeds in order to make sure that they weren't exceeding power envelopes in those kind of maybe unfair or unrealistic application workloads, right?
Yeah, I don't want to call it not real world because it exists, so it's real, right?
Okay, yeah, fair.
But it's not your typical application of what you're going to be seeing when you're gaming, right? It goes well beyond that, and you don't want to design to these non-typical scenarios because it actually harms the performance of real games. So Power Boost was the answer to that. Yes.
I think for both sides, for both major companies in this, when you guys first came out with that stance, you both kind of did it at about the same time, but with different, one with software, one with hardware. There was maybe some initial pullback from the community. It's like, hey, you can't take away Furmark from us. That's how we test power consumption. It's it's a stability benchmark. But I think over time, these gamers have come to realize that it makes sense to take advantage of your abilities to kind of monitor those things and give us. I think most gamers who are going to buy these cards would rather have higher performance in Battlefield 3 than higher performance in Furmark.
Exactly. Yeah. So no, that sums it up very, very well. So the way we did this was we improved our mechanism to estimate power. So estimating power is really the key thing here. And how accurately we can estimate power allows us to determine how close we can go to the absolute upper power threshold of our board design, which is about 250 watts here. So if we're accurate within, say, 10%, and now we've gone and we're accurate to within 5% now, it allows us to push those clocks up another 5% or so, give or take.
Right.
So, and that's what you're seeing. So now we actually have a higher base clock of 1 gigahertz. So that's about 75 megahertz there, all operating within the same power threshold. But we've also added digital temperature estimation, which is a deterministic way of figuring out exactly how much thermal headroom we have on the GPU and the ASIC. So when you're running a benchmark or a game, you're gaming, if it looks like you're not using up all your thermal headroom there, that's when we can actually go into the boost state, increase the voltage, increase the clocks, and not exceed the thermal capacity of the board and have adverse effects. And that's why having this this really high accuracy power estimation comes in play as well.
Now, obviously, this is a technology and a feature that NVIDIA introduced with their Kepler cards, and one of the things that I think AMD was kind of critical of during that launch was the idea that performance was going to vary from card to card, and that a user that bought a 680 today might get a very different card performance. It might be better, it might be worse than their friend that buys one a week later from a different vendor at a different time. Are you still sticking with the even with PowerTune with Boost, that all these cards are going to perform the same for a consumer regardless of which individual GPU they actually get?
Yes, absolutely. And that's the way we want it. We want to have everybody that buys a reference board or a reference clocked product to have the same experience. There's always going to be the end users that want to overclock it further, and we're still leaving that for them. That's still available to them. But as a consumer, I know myself, if I bought a graphics card or a OEM system like some Alienware or someone like that, and I was running a benchmark like 3D Mark or something like that, and had really good performance, but then I found someone else had another system, exact identical, bought from the same configuration, but his was getting 5–6% more performance there and paid the exact same price. I wouldn't necessarily feel very great for that, and that to me doesn't seem like we're giving the best value to everybody there. There's always overclocking headroom for the people that want to do it, and you know, we'll get into some overclocking testing afterwards and look at that as well.
Okay.
So, actually, why don't we get into some demos of PowerBoost here, because I know we were talking a little bit before, and you had some questions about, well, when does it enter boost state? Do we expect it to be boost state all the time? And you had some questions about how to monitor it. We're looking at releasing a public tool that will allow end users to monitor it, but we can actually look at here through a private tool I have here and show exactly how much time it's spending in boost state in a game, and then we can actually throw it into like Furmark, which is the that stress test, and it's actually kind of cool. You wouldn't actually think it, but you actually boost Furmark at times as well.
Okay. So
it really just shows that PowerTune with Boost really maximizes your performance at any given time, even in these very stressful apps.
Okay, we'll go ahead and set that up. Now I should note while he's setting this up, this is not a publicly available tool, and also this tool was not made available to reviewers prior to launch, right? So this is not an application that we had access to beforehand. Though AMD's going to give us a little bit of a preview of. Did it show up on our other?
Yeah, we're looking to enable this this monitoring inside of your traditional Catalyst Control Center overdrive tab.
Yeah, so the currently existing tools like GPU-Z don't have, I guess they weren't written to have access to the new information of these kind of variable P states above and below what existed before, right? So the boost P states and that kind of thing. So they're either going to report 1050, 1050 on this, or they're going to report 1000, or they're going to report the steps down below that. They won't actually report frequencies in between it, even though it is hitting those frequencies.
And those tools get updated pretty frequently too. So you should see something fairly soon. So one of the tests that let's use Metro 2033. Let me just open up the benchmark here.
All right. So we'll swap between this display that we're going to show you here and the 720, where there are other display where we're going to show the monitoring tool. Do we want to show the monitoring tool first as well?
Well, we can start actually, yeah, just go right in there. Okay. And there's a lot of details here, but I'll just show you two things that we're going to look at real quick.
There we go. We can see it. We might be able to see it up there. I don't know if we can.
Yeah. Not seeing on the display, but essentially what we're looking here is it's a counter of how much time we're spending in any of our states. So we have our low, medium, high, and our boost states there.
Okay.
So pretty straightforward. Not much to see there right now. It's sitting in its low power state right now. Why don't we just switch the input back there so I can get the benchmark going, and we'll show exactly how much time it spends in boost. And the amount of time you spend in boost really depends on how power heavy the application is.
Okay. Now, even though you mentioned low, medium, high power states, are there more? Does the GPU have the capability to go more than just those kind of three or four discrete states? Yeah,
there's intermediate steps in between.
But just for the reporting of the tool.
Exactly.
It's there. Okay.
Yes.
All right.
So we'll just kick this off here. DirectX 11 mode. Our resolution on the display. Obviously, the TV is limited to 19 by 10.
It is. Yes.
This card is going to be able to achieve these frame rates very, very easily on this here right now. So you're going to see some high frame rates. But let's just kick it off.
One of my many pet peeves. We're still stuck on 1080p TVs until we get that 4K display to use behind us, and then we'll have you back.
Absolutely.
So we're going to run through Metro 2033. This is kind of the integrated benchmark mode, and we're going to let it run a little bit so that the application will gather some data. The problem is that because Metro won't run in a windowed mode, we actually can't show both running at the same time.
Exactly.
It has to focus in order to set up data real time.
Yeah, we'll demo that in Furmark. Furmark's a good example about that we can do real time. But what you'll see here is on the screen here. There's two columns. There is the time and then the percentage spent there. So what you're going to see now is you're going to see a higher percentage in time calculating up for high state and boost state there. It's a little far on our screens in front of us there.
Yeah, so what you can see there is actually, you'll see like the low state, and that percentage is decreasing because we're running Metro 2033. It's running at the higher boost clocks. It looks like we're down to 64%, 63% on the low end, and that will slowly, because we hadn't reset it until we started the game, right?
Yeah.
But that will be changing, and so that's pretty interesting. It's an interesting way to view the data in terms of a percentage of how often you're at these different levels.
Yeah, it's good. Absolutely. So you're going to see it keeps on running here. And actually, Metro 2033 is one of these applications that really benefits from boost. You're going to see in this application, from the results in the bottom there, it's actually spending a considerable amount of time in the boost state. Whether it's running at the full boost clock of 1050 all the time, or an intermediate state in between. I can't show that because the window that shows actual clocks needs focus, but it's actually spending a good amount of time in boost state. So Metro 2033 is actually an application that really, really benefits from it.
Okay. So when do you think we have enough data to go back?
Well, let's just
run a third
let's run the third one in there and see where it goes.
Okay.
Yeah, unfortunately we can't see it on here.
Yeah, it's odd. Anyway, so what percentage are we looking at up there? So we're about 69% in the high boost state.
Yeah, so we're actually spending a considerable amount of time boosting in this application there. But let's go into something that will allow us to see some more dynamic clocks and do things a little bit more interesting.
Okay.
Let's close this. Let's go into Furmark. So Furmark is one of those applications that we don't need that result. That everybody thinks we're going to start dropping the clocks down and running it at a very low clock through PowerBoost, through PowerTune. But you're going to see through this, and try to pull up graphics.
There we go. I always like that caution.
Yeah, and nobody reads it, right?
That would be boring. So here now we can maybe get a little bit better view of it because we can see things happening in real time with the application kind of running, right? So you can see here that
most of the time we're spending our time in the high state.
Right, so that's interesting. So the boost state down here at the bottom, which would be above 1,000.
Yes.
Right, so very little time is being spent above 1,000 megahertz because this is the game that is maxing out the kind of levels of power.
Exactly. So this is one of the things that PowerTune should be keeping this within the 250 watt budget all the time. It's a very stressful application. And I will click over here. You can see how we're cycling through our clocks here, varying level of clocks. But I will play with this a little bit more so we can actually show what might happen entering different boost states, and I will adjust the PowerTune level to show that we can actually go up from there.
Right.
So this is where it would actually act in a normal manner.
This is PowerTune at work.
Yes.
Right. Maintaining a power level, it has to decrease the clocks in order to do that because of the application specifics of Furmark, right?
Yes.
So that's.
So you're seeing here that it's actually cycling through the clocks, not in like huge chunks. It's a very fine granularity. So this is these power states that we have between the high state and our medium state. So why don't I go into Catalyst Control Center? I'll just stop this here, and we can play with our PowerTune levels and up that a little bit and show that we can actually boost as well.
So this is the Catalyst Control Center that we're all kind of used to. So now by adjusting these power control settings, what are you actually telling the GPU? That it can exceed that 250 watt
by a certain
level?
percentage, yes.
Okay. Okay.
So just reset our data.
All right.
We don't want to display that anymore.
No, we don't need to see that. So here, Furmark again. We'll bring up our monitoring there. So there you go. We're actually seeing a difference right away.
Yeah, you can see we're actually hitting boost state now.
Yeah, so almost a quarter of the time, maybe even a little bit more. Looks like we're getting up close to a third of the time. It's actually running in boost state. And that was because we increased the amount of power that we were allowing the board to use to kind of draw.
Yes, and so that's one of the things that if you've got a good quality power supply, good cooling in your case, you can actually tweak that and get even more out of it just by moving a slider, and boost will do its job. And you can come back and we'll look at the clocks. You can see that we're actually running in boost a good amount of the time. It's cycling between the 1 gigahertz and the boost state, off and on depending on the orientation of orientation. So it's very, very, very dynamic there.
Okay.
So that's PowerTune with Power Boost there in action. It's actually a very, very cool technology, and it's the technology that allows us to actually get a very high base clock and then even go past that on a nice fast GPU.
I know this is just the first product that you're kind of integrating this technology on. Is there any chance of this being applied backdated to other cards, or are we going to see this on other cards released in the future?
It's a feature that's going to be part of the product stack and the feature stack moving forward. It's we've put a lot of time and effort into it. It's actually giving us great results. It's allowing us to get fantastic performance. So it being integrated into future products, yeah, that's definitely on the map.
Okay. All right.
All right. So bounce out of here.
So we want to do any kind of, well, I guess we kind of showed overclocking with
yeah, that was
does overclocking change any now that we have like a different kind of dynamic in the clock speeds?
Overclocking, you will be essentially overclocking the default clock. So you'll be moving it up, and as you move the clocks up, you'll be consuming more power because you're running a higher clock. But that's the nice thing about PowerTune with Boost. It's intelligent, so it will dynamically calculate the available headroom. And if there's still headroom on top of your overclock, it will still try to get to that boost state as well.
So when you're overclocking, you're basically changing the base clock still, and is that 50 megahertz boost capability kind of like a hard-grained speed? It's not going to try to go over that, or
no, that's the top
like that.
end of it. That's the top end of it.
Okay. All right. There we go.
Yeah. All right. So we've talked about the product itself, but let's actually talk about some of the performance as well. So these are our internal data numbers. I know you've got your own up on the website. We can flip to those afterwards. But generally, we've got a number of the top titles out there: Battlefield 3, Crisis 2, Dirt Showdown, fantastic title. We'll get into that later. Metro 2030, which you showed, Skyrim. All these top titles at very high resolutions, 25 by 16, with varying levels of anti-aliasing. We're getting outstanding performance compared to the GTX 680. On average, I would say if you're comparing where we were before with the 7970 non-gigahertz edition to what we have now, it's probably about overall typical like 15% performance gain across the board, but there will be different applications that benefit from a little bit more because of boost if there's available headroom there. But this is your high-res 25x16 panel. We talked about Eyefinity as well. Eyefinity is another fantastic showcase for the GPU power of this board. And when you're pushing that number of pixels with three 1080p panels, the very important thing is frame rates. What's your frame rate? Like if you're 30 and above, you're usually pretty good. But you want to run that high resolution with the eye candy turned on and still keep that minimum frame rate there. So generally across the board, you're going to see in that 3-display configuration, we're getting faster frame rates and consistently above that 30 FPS as well.
And so if the performance delta increases as the resolution increases from you compared to NVIDIA's high-end option, is that frame buffer at work? Is that the architecture itself at work?
It's a combination.
The memory bus width?
Yeah, so we've got tons of memory bandwidth. So you're able to move frame data across from the bus to the GPU very, very fast. We also have 3 gigabytes of memory, which allows you to store more data in local memory without having to transfer it. So you're able to cram more in there without having to worry about the latency of transferring things.
Okay.
And obviously, as you get into 3 displays, well over 4 megapixels. That's really, really important because that's a lot of data you need to store there, especially when you start turning on things like MSAA as well. That requires a lot of frame buffer as well.
I should note, I'm seeing some questions come up in the chat room. We have a couple of guys monitoring the chat room for questions that they're going to feed us, and we'll do some Q&A at the end once we kind of go through the rest of the demos and stuff. We've got some cool demos we're going to go through. Do you want to show the next slide, or you want to go over to the website first?
Yeah, why don't you go through some of your data and reference that?
You'll have to man the keyboard there for us and go back to the desktop here, or escape out of that.
Oh, I lost your...
Yeah, when Metro came up, that's what happened.
Oh, right, it closed it.
Go ahead and head on over to the site there. And I'll just give you, obviously, hopefully, if you guys are watching this, you've been to PCPro.com and you have read our review already. We hit Control++ a couple times. We'll just zoom it in a little bit since there we go. So this is our review. We've obviously gone over a lot of this information here as well. If there's a little bit more detail on what we thought about the boost technology. If we go to some of our benchmarks, you can see we tested Battlefield, Skyrim, Dirt 3, Metro, Deus Ex, and Batman Arkham City. And what I found was interesting, your biggest performance increases came as a combination of hardware and software changes. That we hadn't really seen yet because it had been a little while since we tested the 7970. And so the driver changes actually built for a lot. I'd say Battlefield 3, probably the most popular game still. If we can switch to this screen for a second, there we go. We'll see what I found to be the pattern for performance on this solution or on these cards is that the new 7970 gigahertz edition was usually a little bit slower than the 680 at lower resolution, 1680 by 1050 and maybe even 1920 by 1080. But as the resolution went up, we actually kind of saw that switch. So here you can see 2560 by 1600. The gigahertz edition is just barely faster than the GTX 680. Close enough that you might be able to call it a tie. And then we do test surround testing as well, Eyefinity versus NVIDIA surround, and you'll see some of those performance differences there. So that's kind of how we sum up everything there. Let's look at another game or two in our results. Dirt 3 was one that was always interesting. When the 680 first launched, Dirt 3 was actually a big win for the NVIDIA card. And since then, it has changed dramatically, and that's again a combination of your software on the Catalyst team as well as the increase in clock. So you can see here, even at the low resolutions, the difference between the gigahertz edition and the standard edition of the 7970, and then as we increase the resolution, those differences kind of continue. You can see the difference between 47 and 54 is pretty sizable when we're talking about surround. And I think the last game we'll look at is Batman, because we see similar results there in Batman Arkham City. You guys have optimizations for anti-aliasing now in this game, and whereas at one time this was a clear favorite for the NVIDIA Kepler architecture. Things have shifted now, where even at 1080p you're a little bit faster, and you can see as we hit 2560 by 1600, you know, the difference of 70 frames per second versus 60 frames per second, and you know, it's pretty good. 8 to 9% gains over the original card, all pretty good news.
So yeah, you hit on something really important, and I'll talk to a little bit just before we go back to my next frame there. But you know, Graphics Core Next was a completely new architecture, start to finish, when we launched it in December. So obviously there's a lot of work that goes into getting the software ready for that as well. And as it's a new architecture, we continue to learn how to optimize for that architecture as well.
Okay.
So since December, we've launched two other families of GCN products, the 7800 series and the 7700 series. So we've got considerably more exposure on the nuances and intricacies of that architecture, you know, optimizing the shader compiler so that we're really getting the most out of the architecture. And you know, with the varying sizes of the compute units on the parts, we have different exposure for, you know, smaller frame buffers, 128-bit memory bus widths, 256-bit, 384. So we've got incredible exposure on that product now. And 6 months down the road, what you're seeing here is that we've really optimized the drivers, and that's going to continue to happen with this new architecture as we continue to develop our software. And you pointed it out. So Batman Arkham City was a application that saw huge performance improvements from our driver. So, you know, the 7700 GHz Edition saw about a 30% uplift with 8x MSA.
Now, what is this since the card's released till 12.7?
Yes.
Okay.
From the time that the card was released till now.
Okay.
So the 7870 GHz Edition, nearly just over 60%, and same for the 7970. So there's lots of driver improvements there that you'll continue to see with the GCN architecture.
And these are, you know, you can always make these claims about a lot of smaller titles, but I find it interesting. These are big games: Skyrim, yes, Dirt 3, Batman Arkham City, and while some may say that you were just like kind of addressing things that needed to be addressed, you know, it's always good to see support in the long term for these cards, right? Gamers invest a lot of money. If you're buying a $500, $550, even a $400 or $300 video card, you want to make sure that these companies are going to update things and keep things modern on the software side.
These are very specific titles too, but it's not that we're going out and focus on specific titles. We're improving our driver as a whole. So, you know, these are some, you know, fantastic examples of the improvements that you can see from when the product was introduced to now.
Right.
But it's not saying it's limited to these as well. You know, there's going to be other applications that benefit from as well. And I mentioned that, you know, we've got different architecture, different compute unit sizes, different memory bus interface widths. So you look at the example here. One of the titles, Skyrim, benefited huge from the driver improvements, much more than the 7970 and the 7870. Yeah. So it's, you know, having more products out there, and we've got 3 distinct chips in the 70,000 series product for Graphics Core Next. So you're going to see, you know, some products get, you know, larger gains than others there as we really tune for the specific products there as well.
When will this? So we tested this card with 12.7 beta. When will that be available to viewers and our readers?
I believe that will be happening sometime next week. Best thing to do is take a look on Twitter and follow Catalyst Creator. Okay. That's our software manager, and we'll have some blogs about that when it's coming out. But easiest thing to do, as soon as it goes up there, Andrew puts it on Twitter so everybody can follow it. So follow Catalyst Creator. Okay. The other thing I wanted to mention too, and bring a highlight to, is that we talked about earlier, is this Catalyst Crew feedback that we had on our website a long time ago, but it got buried somehow. We brought it back to the front because we're really interested in hearing from the end users about their experience, and we want them to have a direct line into us where we can actually get very specific information about the problems that they're seeing, rather than someone just going to Catalyst Creator on Twitter saying, I'm having trouble.
Or posting on some random forum and complaining to people. So this is a form that you guys created. It's at...
yeah, I'm going to just tab into it. Yeah. It's www.amd.com/report. And this is our Catalyst Crew feedback form, where you can actually go select your graphics card, the driver you're using, the driver history, tons of information there, and cycle through it. List your symptoms, couple specific applications, other games applications, and submit it, and it will get direct attention from someone at AMD. That gets sent to us. We look at it, and we take these things very, very seriously because we want to give everybody the best possible end-user experience.
Good.
So very excited to have that up live, and with that quick link there, everybody should be able to remember it.
You could be opening yourself up to a lot of feedback from that, which is good. And like, as long as you guys have the capability to kind of take it all in, filter it in, and actually act on it, that's a great way for users to be able to kind of interface with you.
Well, like you said, it's rather than going on some random forum that nobody from AMD has exposure to. This is a way to get your feedback there, and it's structured in a way to actually get the information that we need out of it to actually debug and find out what's going on, to see if it's something specific or something broader as well.
Right.
Okay, so I talked about graphics for our next architecture, and obviously we've been talking about it so much the last little while. And the reason why is because really it's the direction we're moving forward. You're seeing it in our 7700 series up to our 7900 series, but it's really a architecture that has such broad exposure because it's got great gaming performance, but it has great compute performance as well. And the reason why I keep on saying compute, and I say compute because with that broad adoption of this compute-enabled hardware out there, you don't just focus on games, you focus on mainstream applications as well. But the performance you get here from compute, for certain things like ray tracing applications like LuxMark, we can throw that up later. Compute-Mark, which is just a synthetic benchmark, and cryptography. I can't remember what title we're using for that, but it's for
AES type stuff.
Yeah, AES and cryptography. The graphics core next architecture is very, very compute powerful. You look at the performance in some of these synthetic benchmarks above the GTX 670. It's not a 20 or 30% performance advantage in that. It goes well beyond that. Sometimes it's twice as fast. Up to 2.6 times the performance of what you get on a high-end GPU solution from one of our competitors. And that translates to some very, very cool results for these games that are starting to leverage them, which there's a considerable number of them out there right now.
Now, do you know if any of these are using the double precision computing power versus the single precision? Well, I'm just looking at the specs here. So the 7970 GHz edition has theoretical throughput of 4.3 teraflops, which is trillions of floating. Trillions of floating point operations per second, and then 1.08 teraflops in double precision. Which, if real quick description is, it's just the amount of precision in the math.
Exactly, the number of digits after the decimal point, right?
DP tends to be more important for
scientific
computing, servers and that kind of stuff, distributed computing.
Exactly.
Single precision may be more used for, I mean, that's what games are doing, right? That's the performance you get for gaming, but it can also be used for obviously other applications.
Absolutely, absolutely. So you said 4.3 teraflops of single precision performance there.
Yep.
It's actually really easy to remember because it's 4.3 billion transistors on Tahiti as well. So it's a nice one-to-one ratio there too. So it's a very easy thing, 4.3 billion transistors, 4.3 billion teraflops as well. But what is, compute? What does that really mean in games? So back when you came to the tech day in December, or is it late November or December of 2011, we started talking about this Leo demo, this forward plus renderer. So what's a typical renderer in a game or consoles right now? It's deferred shading, right? Deferred shading has a number of advantages. It has a large number of light sources and very efficient shading, and it works on consoles and everything alike very easily, and then can be translated to PC games. But there's a couple of different things that it doesn't address. It doesn't allow you to provide for a lot of complex materials, and when I mean materials, it's like textures and the look and feel of, like, say, someone's skin to their shirt, to like a piece of metal.
Okay.
Doesn't really allow for that very easy because of the deferred shading model. Transparency, like glass and looking through transparent objects. But the big thing in that it doesn't allow for is multi-sample anti-aliasing. You're seeing a lot of talk about post-process anti-aliasing. And post-process anti-aliasing, it's a great technique. You know, we have our morphological anti-aliasing, which we introduced with BART's 6800 series in Catalyst Control Center. But really, that's to address a problem of when you don't have built-in multi-sample anti-aliasing in a game, like a deferred renderer. You know, you can have it in there, but it involves the developer to actually go and specifically code it in there. And if they don't want to do it, because it's difficult, you don't get anti-aliasing, or you get like an off and on switch. You can't really tune it. You can't have 2x, 4x, 8x, or anything like that.
Okay.
So with forward plus rendering, you get compatibility with multi-sample anti-aliasing right off the bat.
So anything that you would have technologically available to you in like the control panel settings or the Catalyst Control Center, you'd be able to use with these forward plus rendering techniques?
Yes, exactly. So, you know, what it is, it's a very nice blend of deferred rendering and your traditional forward rendering. So that's why we call it forward plus. So the Leo demo had a lot of very cool things. You know, what is it doing in compute? We do light culling with compute shaders. So this is where the compute comes in. It allows us to really determine the lighting and do it in a very efficient way, that you couldn't do before if you don't have the compute power behind it.
Okay.
So you can have, this is where you're getting the sort of lighting advantage of multiple lights with deferred shading, but you're doing it in an efficient way with a forward renderer. And
is this using direct compute? Is it using OpenCL? So it's using direct compute. It's not a DirectX thing. It's a direct compute aspect of it. Okay.
Exactly. So this is the compute aspect, and this is something that you're going to start seeing happening more and more in games. There's been games that have been using direct compute to varying degrees in the last little while for HDAO, ambient occlusion, contact hardening shadows, and various things.
Okay.
But now you're actually going to have a rendering technique that leverages it natively.
Okay.
And this is what I'm talking about, the complex materials. Enables you to have multiple material types in there. And then we have indirect lighting. Really, I'm gonna let the demo speak.
It's kind of hard. It's kind of hard to see it in like PDF screenshots, especially we're talking about streaming over the internet and all that. Kind of
so
stuff.
What I'm gonna do is, we've got the Leo demo here. That's why I skipped through these really quickly.
Okay.
The Leo demo has got this great educational mode, and you can actually grab that from developer.amd.com. and run it on your system at home if you have a 7000 series GPU.
Okay.
Let's flip into that and take a look at some of the techniques it has in there. And it actually gives you a nice educational mode and shows you what it's doing. So we'll pop it up here.
So anybody can go download this, and it'll run if you have a 7000 series graphics card. Okay.
So this is the demo that you got to see back in December of last year, and it's been on our developer website. We did update it recently to have this educational mode. So if you've looked at it previously and you didn't see this, the educational mode, you can actually grab the new version, go into Escape, hit Escape, pop into educational mode, and it actually shows you real time what the forward plus render is allowing.
Is there any audio to this that we need to turn up, or is it it's video only?
Yeah, you're not going to get a lot of the audio there. So you can see these are all your point lights in the scene, and you can see there's
2,000 animated lights. Is that, I mean, how would that compare to, say, a modern type of game, right? Like, is that an order of magnitude more? Is it 2 orders more?
It really can vary, right?
Okay.
It really can vary. And this is just sort of the technique that Forward Plus does. You can see the screen's divided into tiles, and the compute shader builds a list of lights that actually starts calculating what's hitting different areas in the scene. So what direct compute is doing is it's doing all these complex calculations in real time and very, very, very fast that you couldn't do previously. And then we have our light culling that shows, you know, shows the indirect light by spawning different light sources in the scene, being able to move it around and shows the different characteristics very, very well.
It's always interesting to see how many layers go into building a single scene, a single frame of imagery that you see on a game or a demo like this.
Yeah, like flipping into something that has like wireframe mode. That's always very, very overwhelming for people. So, the Leo demo, if you've got a 7000 series GPU, I suggest, go grab it, go take a look at it. It's actually really, really cool, and it shows you what can be enabled with this Forward Plus renderer. But this is just a demo, right?
Right.
Proof is in the pudding of what actually gets done in games. So we showed you this 6 months ago. 6 months is, when it comes to game development time, a very, very small window, right?
Yes.
Some games, Duke Nukem Forever. How long was that in development for?
Let's not bring that up.
Yeah. So it can go very, very long development. You're talking on orders of years. So the Forward Plus renderer, everybody got really excited about it because it actually gives you the best of two worlds with a forward renderer and a deferred renderer. Dirt Showdown was a title that released very recently, and this is the first title 6 months afterwards that we showed this demo to fully introduce and incorporate the Forward Plus renderer.
Okay.
And this is really, really, really cool because there's a couple different things that it does. It shows global illumination, it uses the forward renderer, contact hardening shadows, and high definition ambient occlusion.
Oh, there you go. Oh.
Really, the best thing is to show you what this stuff does.
Okay.
For those of you looking right here, we have put a couple of blogs up here. It's a really long URL, but you can probably...
I'm not going to read that off.
Yeah, I'm not going to read that off, but in the replay you can probably take a look at that, or I'll have Ryan or Ken put that up separately. Take a look at our blog. Easy thing to do is blogs.amd.com/play, and I'll actually walk you through some of the performance and tech of this as well. But just some of the images here. So what is advanced lighting? Basically, it allows you to have better lighting and reflectivity and actually have a more realistic scene rather than it just being very static and dynamic.
Okay. So
easiest thing to do is show you when we're flipping it back and forth. So this is our the advanced lighting technique that is enabled by Forward Plus. So very, very dramatic, a very dramatic influence there. So normally you'd have a scene that's actually pretty flat, but you're getting these reflectivity of the materials as you're playing through the game. And actually, when you're playing the game, you don't necessarily notice these things. You just notice a very realistic and vivid experience.
Yeah.
So it's nice to actually take some time and actually drop down in here and show you what you're getting. Global illumination. Global illumination is, for those of you familiar with graphics programming, is a systemic thing that they are. Everybody's trying to use global illumination, but it's a very costly technique.
Okay.
So global illumination basically mimics light in the world. Usually you mimic global illumination with just point lights all over the scene, but that's very costly because you have to have a lot of lights. It's a lot of calculation. So Forward Plus enables to have global illumination, which gives you a very realistic scene here in Dirt Showdown. Ambient occlusion. This is something that we've been putting into our titles since the first DirectX 11 title, which was Dirt 2. Mm-hmm. Still doing that. It just basically allows you to calculate the valleys in between like crevices and stuff like that and adequately show the shadows. But this is the one I really like, is contact hardening shadows. Everybody's seen it when you're in a real world where a shadow doesn't have these really crisp lines, right? It may be crisp very close to the source of the shadow, but as you move further away, the light diffuses, it blurs out a little bit. Contact hardening shadows is something that's enabled by Compute as well, so you get a very realistic shadow experience. So I could talk about the tech in this like till I'm blue in the face. Best thing to do is if you want the details and the specifics of it, go to one of our go to the blog, take a look at it. It's actually very interesting. It dives down into the exact tech of actually what we're doing there. Very, very interesting reading. But
now, at the request of AMD, we actually tested Dirt Showdown quickly yesterday, comparing the 7970 to the GTX 680, and there was a drastic performance difference between the two cards, more so than we had seen in any of the other games. What is the reasoning behind that? Is there just optimizations that you guys have done for these types of technologies that maybe they hadn't thought of or haven't done yet, or how do we kind of explain that?
Well, that's unfortunately I don't have X-ray vision into the operations of the driver and nuances of a competitor, but essentially this forward plus render leverages a lot of compute power, and our GPUs, graphics core Next, we know that compute is something that's going to be becoming more and more popular as now that we have these powerful direct compute and OpenCL enabled GPUs out there. So we're making sure that there's tons of compute power in our GPUs so we can enable features like this in these titles. So it could be, yes, you mentioned maybe a driver. It may be just that the compute power of our 7000 series GPUs really just show some deltas in the architectural decisions that one GPU vendor has made versus another.
Well, I'm sure NVIDIA has been paying attention to the releases of the reviews today, and if there's a fix to adjust some performance, they will definitely be doing that. But this is really cool, and we definitely want to encourage, it's always interesting to see the dynamic between the hardware vendors and the software vendors, right? Because in the end, you guys are just really making hardware, but you always have to come up with ways to kind of take advantage of that hardware, take it to the software developers and say, here's this really cool stuff, please use it. It will help everybody in the long run. I mean, and sometimes it's a kind of a slow, tedious process. Yeah. Sometimes you don't get a kind of a larger name title like Dirt Showdown to do it right away. It takes a couple of iterations to do. So it's good to see some adoption.
Yeah. I'm not sure if you wanted to actually go into the benchmark. The Dirt 3 has a really great benchmark mode, but and show you the action that you get in there. But we can maybe go back to that afterwards.
Yeah, we'll see if we got time at the end. We can definitely do that. It's one of the things that the Dirt titles really implement well is a test mode, so you can easily compare your hardware versus anybody else's, what our benchmarks are, what AMD claims, anything like that.
And the games are just fun.
Yeah,
the games are tons of fun. I really like Dirt Showdown because I like rally racing and simulators, but sometimes you just want to go in there and smash cars.
Yeah, well, if you're going to do that, this is the place.
Yeah, that's the one. So we're really excited about that. I'm excited to get some matches going in the office when I get back there and have some fun once I'm off the road. So the other one is we have a blog for this as well. We have a performance blog and technical blog of it. It's another title we've been working with is Nexus. That is the pronunciation of the name there. It's another title that does have a built-in benchmark there. It's based on the CryEngine 3, so obviously you know how much tech is in CryEngine 3 from Crysis 2. Yeah. But there's some really cool DirectX 11 features there, screen space reflections, motion blur, which is really, really cool. We can go to the blog afterwards if you have time and look at that. We have SSDO, screen space directional occlusion. That's another new feature. Point light shafts, and a depth of field feature. So these are all things that will start leveraging the compute power of the 7900 series. Not every single one of these is compute enabled, but it's the sort of rich feature set, the good gaming graphics horsepower and the compute power that provides these, really, really cool eye candy features there. Cool. And Sniper Elite, this is one that is really nice. Everybody likes the first-person shooters. We just basically go up and melee someone or shoot someone. Sniper Elite's a little bit different. You got to be a little more tactful. Obviously, you're a sniper. You need to sneak up on people.
So it's not like using a sniper rifle in Battlefield 3 where you can just charge headlong in, zoom in at the last second like Ken does, and shoot somebody and then kind of run away, right? It's more realistic, maybe a little.
I sense a little tension.
I'm not very good at Battlefield 3 is what I'm trying to say.
Yeah, but going back to direct compute, super sample anti-aliasing, something people really like, but it's actually very, very intensive to do that. So super sample AA is accelerated by direct compute in this title. Really cool feature there. Contact hardening shadows, HDAO. This is again comes to this basically rich feature set, and this all comes under sort of our gaming evolved umbrella. A lot of people thought our Gaming Evolved was basically just this promotional tool. But Gaming Evolved is really much more than that. It ranges all the way from partner engagement for new technologies like Forward Plus renders, all the way to the promotional like game bundling. So it's actually a really, really great tool that we're using to leverage all this great tech into the games and actually put some really exciting features and draw everybody to the PC gaming experience there.
I think I would say I think many people have negative connotations of both AMD's Gaming Evolved and NVIDIA's the way it's meant to be played and kind of how these entities work. And I'm sure there are differences between them, and I don't have any idea exactly what goes on in either of them, right? There could be things that I don't know about. But the idea, I mean, they're just, you're evangelizing your product, you're evangelizing your hardware, and evangelizing the technologies that you think work best to improve gaming and that kind of stuff. And as long as we get, the biggest, where I think, I don't know if this is where Gaming Evolve launched, but where it became much more important was with like Eyefinity.
Yes.
Right. So Eyefinity launched, and there were very few titles that were properly implementing it, and we're like, wow, this is really cool. This is what we want to see. And now we see almost every title that comes out has support for multiple display resolutions.
Yeah, and you notice here, like we've got our different technology features down here. If you go to amd.com/Eyefinity, I don't know the full breakout of the URL, but we actually have a list of validated Eyefinity titles now. So we work with the developers, we give them feedback if they need to improve something, and we give them sort of like a rating of how great it performs in Eyefinity. Obviously the base requirement is having like HUD centered, having the resolutions available in the GUI, making sure that the screen isn't stretched, you're actually getting an enhanced field of view with the game. And this is the base requirement is for like a 3x1 landscape configuration.
Right.
But for those developers, and Codemasters is fantastic for that. We have many, many more features. Display modes. We have 5x1.
I wish I had enough space for 5x1. That's what I would really like to have. But even really here, I don't really have a space for it yet.
Yeah, but when you sit down and you do it, especially if you get some of the thin bezel monitors like the Samsungs that I had on my desk for a brief moment a while ago, and then they got taken away.
We'll have to check. Are those Cat Leap monitors? They have thin bezels? I don't think they were.
I've seen some people actually go and taking the bezels off their monitors
doesn't
too.
Sound very like a good idea to me.
It's every but one of those things.
Risk.
Yeah, it's fun. You do what you have to, but Eyefinity is so immersive. Even if you have a larger bezel there, once you start looking at it, you get so absorbed into it, the bezels fade away, and especially with bezel compensation where it blends very easily.
Right.
It really gives a very immersive experience out there. But Compute has two folds, right? We've got the gaming side of it, but I also mentioned the mainstream application side of it.
And I think we've got a really, really good example of it we're going to show.
So this is just sort of the performance that you see with these GCN optimized titles that take advantage of the compute. Compared to the competition, like with the compute power of the 7970 GHz edition, you can get exponentially better performance out of it in these titles. And when it could be coming down to driver optimizations, exposure to it as well.
Right.
We'll see how it pans out, but these titles here really leverage the power and efficiency of our 7900 series. But what's important is this mainstream adoption. People like the game, but use your computer. I know for myself, I game a sliver of the time, but my day-to-day tasks, being media, photo editing, either with like a consumer application like Photoshop or open source like GIMP. Even little things like zipping a file with WinZip. These are all the types of things that can be accelerated by GPU compute. WinZip, everybody's used WinZip.
Yep.
It's, with the amount of storage you have on a hard drive these days, if you need to make an archive of something like photos, like you can be zipping up photos gigabytes. Or say you have a game folder that you want to just zip up and archive and move to another system, because you have this issue all the time.
I do that a lot, yes.
So having a GPU accelerated zipping program for say something that's maybe 5 or 6 gigabytes, that takes a long time on its own. So anytime you can save while doing that, zipping and uncompressing, saves you time in the long run. So accelerated zipping with WinZip is fantastic, but I really like Handbrake. Everybody loves their media. I have two phones. I have a BlackBerry. I've got an Android. You know, you have your media streamers like your Xbox 360. You've got your PC. Everybody has these different devices: tablets, iPods, iPhones, and you always have an original file, something being like a home movie, wedding video, or something like that, and you need to move it around. And changing the encoding formats, downscaling the resolutions. If it's a large file, it takes quite some time, right?
Yeah, it can, definitely.
So what Handbrake does, you know, allows you to do it now, OpenCL accelerated. So they've gone and actually done their own OpenCL coding for this to accelerate GPU transcoding.
So this is actually really exciting for me because I think any of our viewers and readers are going to know that Handbrake is probably the most popular one. And we have gone through so many iterations of GPU transcoding, from the stuff that was not very good, like to be honest, the tool that was integrated in the ATI control panel at one point. You know, we've seen Bada Boom, we've seen all these kind of not very good applications, good demos of the technology, but not very good applications in general, right? They're not one that enthusiasts are going to use. Handbrake is one of those.
Yeah.
And if we see actual real-world benefits out of it, that's awesome, and that starts us down the path that we need to be on for GPU computing.
Absolutely. I'm really excited about it. I'm excited to get a copy of this when they release it formally, once they go through the review process on the and get it into their nightly builds.
Okay.
But you know, I'll show you some of the performance numbers that you're getting performance over this with this OpenCL acceleration. And then we'll actually go into it, and I'll show you how much time it takes to encode a 9-minute clip down to something to fit like on your iPod. And it's actually, you know, everybody's gotten used to this almost a 1-for-1 ratio for encoding best case. If you have a high-end multi-core CPU, sometimes you can improve on that.
Right.
But not everybody has, you know, $1,000 CPUs or anything like that. But everybody has a GPU in their system, whether it, you know, is an integrated GPU, like one of our APUs, like Llano or Trinity. Or, you know, you have a 7750, which, you know, is a GPU that costs around $100. So it's very attainable for everybody. And you look, we're on the scale of 1.3 to 1.4 times faster than the GTX 680 in an OpenCL encoding scenario for these. So it just goes to show you that, you know, making sure you've got a very well-rounded GPU that focuses on everything, you know, gaming and compute, is very important in this time and age when, you know, compute's really starting to become mainstream with all the installed compute-enabled GPUs. Do we know when this full version of Handbrake is actually going to be released? Do you have any ideas? I'll have to get back to you. Okay. I know they're looking at going through, their board is looking to go through the review process to get it released in their mainline. Handbrake, since it's a tool that is so widely used by everybody, they want to make sure that it's a fantastic experience for everyone, right? It's, you know, it's the reason we use it is because it's perfectly stable and it works all of the time. We don't want to change that now. Exactly. So they're going through the process, but this is a. Let me just switch here. Control. Let's just go into our Handbrake, and I'll show you just sort of how fast it goes through here, up top. Yeah. And I believe for our source file, we're going to use the ever-present Big Buck Bunny. Big Buck Bunny. So this is a 720p clip. It's 600 megs. It's just under a 10-minute clip, and we're going to convert it down to, you know, an iPod form. Okay. You know, very, very common use case there. Sure. You know, everybody and their mother has a iPod these days, it seems. So. Okay. Let's get my source. Just go to iPod. So it's going to take the source from 720p and convert it down to a 480p configuration there, essentially. Okay. So let's just start. Should probably set my source file, my destination. I'll just copy over the one I did earlier. All right. So the cool thing to look down here is the FPS, the frames per second that it's doing. We're converting over 600 frames a second on this encoding. So typically, video is 24p.
I don't think in my versions of Handbrake it gives us this detailed of information. I'm hoping they'll do that so that what I would like to see is, I want that result to stay up there long enough so we can use it as a benchmark, right? So we can kind of see what the output of that is. But that's impressive. And that's all OpenCL. That's not a custom AMD implementation or anything like that.
Yes, they went and did it completely in OpenCL from the ground up in there. So they wrote the encoder themselves, the transcoding algorithm themselves.
Right.
So they've got the control from start to finish. And by being OpenCL in the nature, it should work on any OpenCL compliant processor.
Okay.
So that was a 9-minute clip, and I missed how quickly that went because it went by that fast, right?
It was very fast, yeah.
So this is going to be great for people that are on the road, that have Blu-rays or stuff they want to throw on their laptop, but I don't know how many laptops have 1080p screens. You're lucky if you got a 780p sometimes. So it allows you to convert it down really quickly, throw it on your handheld device, your tablet, and take your media with you wherever you go, and you're not going to be chained to your desktop machine just encoding stuff nonstop, night and day.
Yeah. So, okay, when are these cards going to be available? We talked about, I think we mentioned the price really early, $499. So this now goes directly head-to-head against the GTX 680, and I think it's great news that it's actually $50 less than the initial launching price of the original 7970. While price wars benefit us, I know they're not great for AMD, but we love to see the competition. We love to see the prices come down. We want to see these types of powerful products in more people's hands, as many people as possible. So.
Yeah, but these products here, you're going to probably see on the shelves within the next 10 days or so.
Okay.
This is our reference design here. It's got our AMD designed shroud.
This one I can show you here. I mean, if you have seen the 7970 before, it's basically identical.
Yes.
Right. I mean, where in terms of the reference card design, you can see the output configuration there. Still two mini DisplayPort HDMI, dual link DVI. And in terms of power connections, an 8-pin and a 6-pin, right? And
yes.
Support for crossfire.
Yeah, four-way crossfire.
Right? So, yeah.
So what you'll see is this is our reference design that we've provided to sites like PC Perspective, just so you can do evaluations of performance.
Right.
You're going to see partner boards like Asus, Gigabyte, MSI, everybody with similar designs, possibly tweaked designs of what you saw for the 7900. Mm-hmm. Series products before with their own custom coolers, boards that are built with higher power limits for higher overclocking headroom. You're going to see a number of unique designs when these end up in retail in the next 10 days or so. But as it is right now, you know what the product is, and I really expect these to start really sort of flying off the shelves when they get out there, especially with the performance. What you can see with these compute-enabled applications, like WinZip with OpenCL acceleration, a 6 gig file, you can shave off 3 minutes of your compression time compared to just using straight CPU with no OpenCL. And this is with a high-end GPU. This is high-end 6-core CPU, so you get a lot of performance improvement there. And one of the things I did mention, Adobe Photoshop and GIMP. Adobe Photoshop is the leader for paid photo editing. What they've done with Photoshop CS6 is they have actually moved away from proprietary technologies like CUDA, and they're actually enabling OpenCL. OpenCL, since it works on every GPU that's OpenCL capable, they're moving to this. So that's what you're seeing with this wide adoption of compute now. This
was exactly what we thought was going to happen. Once we learned about OpenCL and we saw the implementations of it, we knew that these kinds of software packages were going to move from using any kind of proprietary solution, whether it was NVIDIA's or AMD's from the early life, and come back this direction. So.
Yeah, and it really, you have to have the API there, then you need the hardware, and then you need the software ecosystem.
It takes time. It takes time. These transitions do. So,
yeah, and you look at the ecosystem for Eyefinity. When like you mentioned it yourself, like games when they came out, very few of them supported Eyefinity properly. You might have to go into a config file, set the aspect ratios properly, the field of view. Some worked great, some didn't. You know, sometimes the HUD was over here, sometimes things intersected with the bezel. You know, it's efforts like Gaming Evolved that we actually go work with developers. We provided the ATI display library, which provides access into the GPU, our driver, to actually figure out, you know, where are the bezels, where are everything, right?
Right.
It takes time, and you look at how great the experience is on Eyefinity on these titles now. It's incredible, and you know that's under 2 years. And obviously, there's tons of applications there that are going to be compute-enabled. So those are just a few. You know, anybody that does video editing, they know Vegas Pro. You know, we've got our other conversion tools out there. So those are four that I mentioned before that were very new. But there's tons of different compute-enabled applications out there too.
Cool.
So that's it for what I had to talk about the product specifically. I guess maybe we can.
So we've started feeding in some questions. We're going to do a Q&A session here, and we're going to give away to the questions that we answer a free copy of Dirt Showdown. So I've got some keys. I guess they're Steam keys, right?
Yeah, they're Steam keys.
For Dirt Showdown, so I can give them out to whoever. So we've got some questions in here that we will filter through. Let's see. So Forever ATI wanted to know about if AMD had any plans for a solution like NVIDIA's adaptive VSync, the capability to run, to lock your frame rate at 60 hertz when it would normally go over it, but allow it to scale smoothly below it. Is that something that you guys would see a benefit in?
You know, obviously we're always looking at our software and our driver to see what features make most sense. Obviously, we haven't vetted out everything. It is an interesting technique, and we're always looking at different ways to provide that better experience. Adaptive VSync was very, very cool. I haven't had a chance to play with it much myself. I've just seen, you know, articles on it detailing it. You know, there's a lot of different things out there that we're thinking about bringing. Obviously, you know, we've got Eyefinity and our Eyefinity technology, HG3D. And what we need to do is we need to focus on technologies that really address the broad software stack. VSync is something that, you know, we're going to take a look at and see what we can do. Obviously, put our own AMD twist on anything we do to make sure it's actually providing the best end user experience there. Don't really have an absolute answer to that because, you know, obviously that's a very new feature that we saw from NVIDIA. It's cool. What we might go from there and improve on is TBD right now.
Another thing is, we only got one of these cards in so far, so we weren't able to test Crossfire. Does your implementation of Boost, PowerTune with Boost, change anything in the Crossfire dynamic?
Well, actually, it's kind of interesting you raise that up, because obviously you have two GPUs, and they can be loaded differently. They have different frames, and the primary GPU, the first GPU, has the overhead of doing all the rendering out and display. So what you'll actually see is probably the secondary GPU entering Boost a little bit more frequently, a little bit more often, because it is just feeding everything to the primary GPU, doing that second frame in an AFR scenario. So,
so they will be able to operate at different frequencies, but still complete the tasks, you know, the Crossfire.
Exactly.
Okay.
Exactly.
You know, on kind of a side note, tangent, how have you guys done any work internally or anything on the whole idea of stuttering, micro stuttering, frame metering, things like that? And are there any? Have there been any changes to the Crossfire architecture recently, or do you guys have any plans for that in terms of micro stutter and that kind of thing? And I do want to apologize to people in the audio if you happen to hear lawnmowers coming through behind us. It's wonderful timing by our crew outside.
Yeah, no, that's interesting things you touched on there. And I did hear it over the lawnmower too.
Good, good to know.
You know, micro stuttering, it's one of those interesting phenomenons that not everybody sees it, and it can come up in different scenarios. Obviously, we want to make sure that everybody has a great experience overall. And what I would suggest to you is, take a look at our solution. I think, microstarting is a difficult thing to capture, but definitely the way our GPUs are working across right now with boost, making sure we can have high clocks, and being able to keep everything in local frame buffer at the high resolutions, making sure we keep the minimum frame rates really high, and being a PC Express Gen 3 graphics card, we're always looking at the hardware to make sure we can minimize that as well. But if there's anything we can do in the software as well to address things like that, we're always looking at it.
Okay.
It's one of those things, like you said, not everybody might know about it because you don't know about it until you actually see it. And it could manifest in very, very weird ways. It could manifest itself in a scenario where at lower frame rates, you don't see it, but when you have a really high frame rate and then you have a pause, it could manifest it in the high frame rates, not the low frame rates. It's kind of one of those things that's very, very tricky to see, and it could, in different scenarios, just pop up different ways. But we're always looking to improve that. If there's any concrete way we can address that, we'll always let you know about that when something's coming up.
All right. I do like that our lawn care professionals are making a guest appearance in the show. So let's see. We have some more questions in here. Water-cooled versions of the card. Obviously, that's more of a partner-specific thing. But do you know? You don't have to give us specifics. If you can, that's awesome. But are there going to be? I've seen a lot of chat and scrolling by about wanting single-slot versions of these types of cards.
So, do you mean like a reference design that's water-cooled from AMD?
No,
or?
I think they're more looking. I mean, I think we assume that it's going to be a partner-based product.
Absolutely. So you saw there's a huge variety of aftermarket coolers out there for the 7000 series products already. The nice thing about this is that from the reference design perspective, you said it yourself, it looks very similar to the reference design we showed you back in December. That hasn't changed. The layout is very similar. So there's nothing to say that water cooling won't be available on this. I don't know any specific vendors off the top of my head that are offering it, but if a water cooling vendor has a solution that fits on a current board, it will work on the new GHz Edition boards as well.
Okay. Now we've seen this one come through. I knew it was going to come up. It's possible, since there was rumors of a new Radeon graphics card solution being released today, that maybe they thought it was going to be that elusive Radeon 7990. Do we have any news or updates on a multi-GPU variant of Tahiti?
Well, we've been talking about it. Definitely, it's on our roadmap, and we'll just have to wait and see for that. I know. Everybody's probably referencing this picture in question from AFDS.
Right, there was that. I mean, you guys mentioned it publicly at the initial launch of Tahiti, right? You showed up the code name of New Zealand and all that kind of deal. So, like, it's something we've been kind of expecting a little bit. So,
yeah,
not just us, but those guys.
It's still on a roadmap. Will be coming in the future. You saw something that looks kind of familiar, like it might be a big GPU being held up by someone at AFDS, so I guess we'll have to wait and see.
I guess in the same relation, they were wondering if partners could release a dual Tahiti version, kind of like a custom one. Asus has done this in the past with the Ares cards, I believe, and the Mars cards. They've kind of hacked together their own version of it, and I'm sure that's still possible if they want to spend the time and money to do that dev. Absolutely.
So no, I don't know if anything came out of Compute-centric a couple of weeks ago of like unreleased board designs from partners.
Not in particular. I don't remember seeing anything.
I can't
on
remember. No, we haven't limited anybody. If Asus wants to go and do something like that, I think it's fantastic. They have great solutions for stuff like that.
Right.
Very interesting. Like they're different
large usually too.
Yeah, they're not for everyone.
No, and they freely admit that, and it kind of adds to the cachet of
it's really cool. It's nice having something that you and only a few other people have. Like, I know we did the 5970 designs with XFX and Asus and Sapphire. You know, that's the example of, there's some of the great talent in our board partners and the custom designs that they do out there. And usually they're a limited production run, probably 1,000 or so units or stuff like that. So, as soon as you see one of those pop up and it's announced, get your orders in, right?
If you got the money for it.
Yeah, yeah.
Jay wants to know if we have, I think we may have asked this earlier, but I'm going to ask again just because. Do we have any idea or time frames on when the Catalyst Control Center will be updated with those features?
It's still a work in progress. Obviously, it's a new feature. It's something that we're considering, something that was raised literally a week ago by press like yourself. So obviously, it's not an overnight thing. It needs to go through testing, needs to be implemented, and be done so in a stable and productive manner. And what everybody needs to understand is that we do have our beta drivers, which give early sneak peeks. But with WCL drivers and everything, drivers need to be sort of locked down and going through a rigorous software QA process well before it actually gets posted to the web. So we're looking at what we can do and how we can get that out as soon as possible, and we'll let you guys know. And like I said, any news about Catalyst driver postings and stuff like that, always take a look at Andrew's Catalyst Creator Twitter handle there. It's very good information out there.
All right, maybe just a couple more. Nilblog wants to know, will these Catalyst drivers that we're talking about performance increases as the software has improved on the driver side, does that affect users that have 6000 series cards already, or is the maybe a little bit, but the majority of the change is coming because of the new GCN?
Exactly. So if there's something that can be done across the board for our entire GPU family, including older ones, we're always going to look at that, especially like if it's a new title that there's some new tech in it and there's some really cool stuff. If we optimize something, it usually benefits all of our products across the board. But at a base level, from the shader compiler and the base driver, the VLIW5 products and the VLIW4 products that were for the 6000 series and previous, we've been doing that for a number of years. We've really, really, really optimized performance for those products. So, if it's specific game improvements, yes, you'll see it for older products. But in terms of improving the overall driver performance across the board, you're going to see more significant improvements for that for the 7000 series and the graphics core next processors specifically.
And let's at least one more. Tellus006 wants to know, we've had these little switches on the top of the GPUs. I believe it was the 6900 that had a switch to let you select what kind of performance mode you were going in. And that wasn't the case with the 7000s.
Well, on the 6970 and 6950, it was always the same VBIOS on both.
Okay.
It was the 6990 that had two different settings.
That's right.
But really, two different performance modes. Really what this is one is a safe default VBIOS. Another one is something that an end user can update. So if they want to flash it to a higher clock.
Is that feature still available on the 7000 series cards?
It's usually on our highest end GPUs like Tahiti or Cayman. So you'll see it on the 7900 series because people are buying these cards. These are the real enthusiasts that like flashing their stuff, and there's nothing worse than being in a panic that you've bricked a graphics card. So you can flash it in one of the BIOS positions. If it doesn't work, you can always go back to the BIOS you have on the other position and go back and flash other one. It's you can, when the card boots, it'll read over whatever the switch is on, and then you can flick it and go into a BIOS flash tool and update the secondary one and see what you really can get out of it.
Okay. Well, I think that is going to about round up. I make sure round up the show on the Radeon HD 7970. I really appreciate you coming down and spending some time with us and explaining to our viewers and readers a little bit more detail about it. If you haven't checked out our review of this card, you definitely need to go to pcper.com. We talked a little bit about performance and boost technology and power consumption and all that kind of stuff, but you can get all those details in more granular detail, I guess, in our review at pcpro.com, and then you can come back here and reference this. And we really appreciate everybody stopping by. And sorry about the little hassle at the beginning, but we did eventually get it worked out. And so yeah, thanks again for stopping by. Anything else you want to close with before we?
I want to say thanks for having me by your studio here. It's been a while since I saw you face to face, so it's nice to see you. It's been a couple of years, I guess, and definitely appreciate the attention that you've been giving our graphics cards the last little while, and couldn't do it without you.
Thank you very much. Make sure you check out our live feed tomorrow, where we will, I will attempt to build a Llano-based PC completely blindfolded without cutting off a finger or something like that. So that should be more exciting. If you thought the build up to this was exciting because we didn't know if we were going to get it working, wait till you see if we can get this PC to work in the dark, essentially. So thank you, everybody, for joining us, and we will see you again soon for another PC Perspective live review.